Let us move to the next sum, that is question number 5. Question number 5 is the first term of an AP is 5 given A equals to 5. The last term is 45. You can write AN or TN. I am writing TN equals to 45. And the sum is 400. SN equals to 400. And what we have to find? To find the number of terms, to find n and number 2 common difference, that is d. So let us start. These are the 3 given parts, these are the required to find parts, and let us start the solution. So I am writing the solution over here. SOLN dot solution. With A I cannot start, so let us start with TN. TN equals to 45 implies A plus n minus 1 into D equals to 45. Now A value is given, so 5 plus n minus 1 into D equals to 45. This implies n minus 1 into D equals to 40. And neither n nor D value is given, so let it be equation number 1. Now SN is given as 400. Now this implies n by 2, the first term plus of last term equals to 400. This here last term is given, Tn is last term also, no? L equals to the last term. So n by 2 and A value is 5 and L value is 45. So this equals to 400. This implies n by 2 equals to 400 by 50. So this will be equals to 8. This implies n equals to 16. Let us make it equation number 2. Therefore 1 implies 16 minus 1 into D equals to 40. This implies D is equals to 40 by 15 equals to 8 by 3. Once let me see the answer, because 5.3 question number 5. It's correct. So therefore n equals to 16 and D equals to 8 by 3 is the answer. Moving to question number 6. The first and the last term of an AP are 17 and 350. So I am writing directly. Given the first and the last term, so A and Tn equals to L is given as, first term is given as 17 and the last term is given as 350. Common difference D is given as 9. How many terms are there and what is their sum? So, and to find number 1, how many terms, and number 2, what we have to find? What is their sum? Sn. Let us start the solution. With A I cannot start, with Tn I can start. So Tn equals to 350 implies A plus n minus 1 into D equals to 350. This implies 17 plus n minus 1 into 9 equals to 350. This implies n minus 1 equals to 350 minus 17 by 9. Now 350 50 minus 17. 50 minus of 17. 10 minus 7 is 3. 4 minus 1 is 3. So over here 333. 333 by 9. So 3 3s are, and over here 1 1 1. Then 3 1s are, and 3 3s are, and 3 7s are. This implies n equals to 37 plus 1 equals to 38. Now, therefore, Sn equals to n by 2, first term plus last term we can use, and n value is 38 by 2, and a value is 17, and L value is 350. So this will be equals to 2 1 and 2 9, and over here 367. So this will be equals to 367 into 19. 6973. Here in place of Sn I can write S38, implies S38. So let us once see the answer. Question number 6, 6973, and n equals to 38. Therefore n equals to 38 and Sn equals to 6973, and this is the answer. So in this sum also, with the given parts, I means writing the formula, you proceed, you will be definitely getting the answer. All sums of AP are means arithmetic based, algebra based, calculation based. So I'm sure all of you can do each and every sum. Question number 7. Question number, the last 6 I did now. Question number 7. Find the sum of the first 22 sums of an AP. So I'm writing the given part only. Given n equals to 22, in which d is equals to 7, and 22nd term T22 equals to 149. And what we have to find? To find the sum of the first 22 terms of an AP. So S22 of an AP. Only S22 we have to find. So let us start the solution. With n and d I cannot start. T22 formula I have. T22 equals to 122. This implies A plus 21D equals to 149. This implies A value is not given. A value is not given. So A plus 21 into 7 equals to 149. This implies A equals to 149 minus 147. This implies A equals to 2. And D value is given as 7. Therefore, S22 equals to, with first term last term also I can do, n by 2 and first term plus last term, that is T22. Over here you can write in place of L, you can write over here T22. So over here 11, and first term we have calculated as 2 and 22nd term is 149. So this will be equals to 11 into 151. So answer will be 1661. Let me check once. Question number 7. Yes, 1661. So this is the answer. Next, question number 8. Question number 8 is, find the sum of the first 51 terms of an AP. So given n equals to 51 terms of an AP whose second and third term are 14 and 18. So T2 equals to 14 and T3 equals to 18. Find the sum of the first 51 terms, and we have to find S51, sum of the first 51 terms. So let us start the solution. With n I cannot start. N equals to 51 and D is equals to T3 minus of T2 equals to 18 minus of 14 equals to 4. Therefore, I can directly put, I suppose, Sn equals to n by 2 2a plus n minus 1 into D. No, I cannot put, because over here so I have to get the value of a also, no? So let us use this formula. T2 is equals to 14 implies a plus D equals to 14 and T3 equals to 18 implies a plus 2D equals to 18. Here we can substitute also the value of D. So this implies a plus 4 equals to 14. This implies a equals to 14 minus of 4 equals to 10. In this way also we can do, or over here by solving these two also we can get the answer. So therefore S51 equals to n by 2 2a plus 51 minus 1, that is 50 into D. 2a plus n minus 1 into D. This will be equals to 51 by 2, 2 into 10 plus of 50 into D value is 4. So this will be equals to 51 by 2, 20 plus 200. So this will be equals to 51 by 2 into 220, which is equals to 110 into 51. So 110 into 51 will be equals to 5610. So S50 and question number 8, 5610. Yes, it is correct, and this is the, therefore S51 equals to 5610, and this will be the answer. Question number 9. Question number 9, it is given that the sum of the first 7 terms is 49, the sum of the first 17 terms is 289, and we have to find Sn. Now obviously over here n is not given, and so the answer of Sn or the value of Sn will be in terms of n only. So we are to find the value of a and d, so with the given concepts, with the given facts, that is S7 and S17. Now S7 is 49. Formula for Sn is n by 2 2a plus n minus 1 into D. So we can write over here, in place of n we will write over here 7. So 7 by 2 2a plus 7 minus 1, that is 6d equals to 49. Now over here 2a plus 6d, and this term will go this side as in the form of 2 by 7. So 49 into 2 by 7 will give over here 7. Sorry, we'll give over here 14. Now this 2 cancel from both the sides. We will be getting a plus 3d equals to 7. Again the second concept which is given is S17. S17 is 289, and following in the same manner we will be getting a linear equation over here as a plus 8d equals to 17. So equation 1 says that a plus 3d equals to 7, and equation 2 says that a plus 8d equals to 7. So subtract it. So 8d minus 3 will be 5d, and 17 minus 7 is 10. So we are getting d is equals to 2. Now putting d equals to 2 in either of the equations 1 and 2, we will be getting the value of a as 1. So we have got the value of d, we have got the value of a. Therefore Sn equals to n by 2 2a plus n minus 1 into d. We will be putting the value of a and d as 1 and 2 respectively. So we are getting n by 2, 2 into 1 plus n minus 1 into 2, opening of the bracket over here. So n by 2, 2 plus 2n minus 2, this 2 will be cancelled and we are getting n by 2 into 2n, that is n square. So answer is n square, that is sum till n terms is n square. Now let us move to question number 10. Question number 10 says that show that A1, A2 up to so on till AN form an AP where AN is defined, where AN means nth term, AN is defined as below, and number 1 it is given as AN equals to 3 plus 4n. Now children, whenever such sum comes where nth term or the sum till n terms is given in terms of n, obviously we are getting the value of A1, A2, A3 and so on by putting n equals to 1, 2, 3 and so on. Similarly, if Sn is given that Sn equals to suppose 3 plus 4n, then we will be getting S1, S2, S3, S4 and so on by putting n equals to 1, 2, 3, 4 and so on. So let us do this sum as follows. Solution. Here An equals to 3 plus of 4n. Putting n equals to 1, 2, 3 and so on. We get A1 equals to 3 plus 4 into 1 equals to 7. 3 plus 4 equals to 7. A2 equals to 3 plus 4 into 2 equals to 3 into 8, plus 8 equals to 11. A3 equals to 3 plus 4 into 3 equals to 3 plus 12 equals to 15. Therefore, we have to prove that it forms an AP. Now, A2 minus of A1 equals to 11 minus 7 equals to 4. And A3 minus of A2 equals to 15 minus of 11 equals to 4. Therefore, A3 minus A2 equals to A2 minus A1 equals to common difference equals to D. Therefore, the given AP, given sequence, we can say given sequence is in AP because the common difference is same. That is, we can write over that is common difference is same. Therefore, the given sequence is in AP. Similarly, tens part number 2, you please do by your own. Let us move to the next question, that is question number 11. Question number 11 is saying that if the sum of the first n terms of an AP is, so I am starting with the given part only, given. If the sum of the first n terms of an AP, sum of the first n terms of an AP is 4n minus of n square. What is the first term? To find what is the first term, T1 equals to S1 also we can say. What is the sum of the first two terms? T1 plus T2. Sum of the first two terms T1 plus T2, that is S2 it is asking. What is the second term? Similarly, Find the third, 10th and the 9th term. Third, 10th and the nth term and Tn. So we have to find this much. And only the thing is given which is Sn. Right now I was talking about in the last question. Now let us start the solution. Here Sn equals to 4n minus of n square. Then S1 equals to T1 equals to 4 into 1 minus of 1 square equals to 4 minus 1 equals to 3. That is the first term is 3. Now S2 is how much? T1 plus of T2. The sum of the first two terms is called S2. Now S2 we can get by putting n equals to 2 as 4 into 2 minus of 2 square equals to 8 minus of 4 equals to 4. So we are getting T1 plus T2 as 4 and T1 as 3. Therefore T2 equals to, we can write over here T1 plus of T2 minus of T1 equals to 4 minus of 3 equals to 1. So we have got T1, we have got T1 plus T2. Where is T1? This first. Number 2 we have got. Number 3 also we have got. And number 4 we have to find T3, T10 and Tn. So now we can write, therefore A, that is the first term, is T1 is 3 and D we can write as T2 minus of T1 and T2 is how much? 1 minus of 4 equals to minus of 3. So we have got this T2, where is T2? T2 is 1, okay, and T1 is 3, very sorry, T1 is 3, so this is minus 2. So we have got the first term and the common difference. Now we can get T3 directly as T2 plus of D, or we can utilize the formula as well. So for number 4 I am starting T3 is equals to A plus of 2D, I am writing using the formula, is equals to 3 plus 2 into minus 2 equals to minus 1, and T10 equals to A plus of 9D equals to 3 plus of 9 into minus 2 equals to 3 minus of 18 equals to minus of 15, and Tn equals to A plus n minus of 1 into D. Now this will be equals to 3 plus n minus of 1 into minus of 2 equals to 3 minus of 2n plus of 2 equals to 5 minus of 2n. Now this sum, what I have done first, this T1 is S1. Now putting n equals to 1, we got the value of S1, which is the value of the first term. Now getting the second term is T1 plus T2, that is S2. For the second term, we first calculated S2. S2 is 4. Therefore T2, we can write over here S2 minus S1. We can write over here S2 minus S1 also. So this will be equal to T1 plus T2 minus of T1. Now T1 plus T2 is 4 and T1 is how much? T1 is 3. So 4 minus 3, that is 1. So we got the common difference as over here the S2 minus of this S1 also we can do, or we can write over here T2 minus of T1. Now T2 we have got as T2, where is T2? T2 is 1 and T1 is 3. So we can get the value as 1 minus of 3, that is minus of 2. Now over here I want to say, children, that we can get the value of T2 as S2 minus of S1 also, using the formula as Sn equals to Sn minus of Sn minus 1. If you remember, I have given one formula. So over here, since we have got the value of this S2 as 4 and S1 as 3, so T2 we can get by using this formula as well. Okay? Now over here d we can also write. Over here I have written t2 minus of t1. Now in terms of the sum of the terms, you can take over here s1 equals to t1 and s2 equals to t1 plus of t1 plus of t2, and the common difference if we talk about will be equals to t1 over here t2 minus of t1. So if we talk about t1 plus t2 minus of t1, we will be getting t2 only. So we cannot write the common difference as s2 minus of s1. This will be wrong. Okay? So common difference is t2, term 2 minus term 1, or a difference of the any two terms only. So I think now you understand. So term 2 we can also write as s2 minus of s1. Now once we get the value of a and d, then the rest of the terms are only utilization of the given facts. So t3 is a plus 2d. Also we can write this as t2 plus d. Both are the same things. So we are getting t3 as minus 1, t10 as minus 15, and tn as 5 minus of 2n, because we are not knowing the value of n. That's why tn is this much. Once let me get the answer. 5.3 question number 11. S1 is 3, okay. S2 is 4, okay. A2 is 1. A2 means term 2. Term 2 is 1, okay. Then S3 is 3. S3 have it asked? Question number 11. S3, what is the sum of the first two term? What is the second term? And similarly find the third, the 10th and the nth term. No, S3 has not been asked. I don't know why this answer is given. Okay, it has used for term 3. See over here in the answer it is written A3, that is term 3 is equals to S3 minus of S2. So it has used this formula for finding the term 3, that is T3 is equal to S3 minus of S2. This also you can do. Now A10, again A10 is equals to S10 minus of S9. So in place of n you can put over here 10 and 9 respectively, and you will get the answer. Similarly an is equals to direct utilization over here Sn minus of Sn minus 1, and by putting n equals to n and n minus 1 respectively, you will be getting over here f5 minus of 2n. So whichever way you apply, children, but the thing is that you should understand both the formulas. Now we will be moving to the next sum, but this sum once you try to calculate all the required values by using the formula Tn equals to Sn minus 1 as well. Definitely you will be getting the same answer, but doing a sum by two methods will help you only afterwards. So let us move to question number 12. Question number 12. Question number 12 is saying that find the sum of the first 40 positive integers divisible by 6. Now here the given AP is first 40 positive integers divisible by 6. So first integer divisible by 6 is 6. And so on. So I have written the table actually of 6. 6 1 ja, 6 2 ja, 6 3 ja, 6 4 ja, 6 5 ja, and so on. So here clearly A equals to 6 and D equals to 6. Now therefore first 40 positive integers, S40 we have to find. S40 is equals to n by 2 2a plus 39d, n minus 1 into d, equals to 20 into 2 into 6 plus 39 into 6. So equals to 20 into 6, and 2 plus 39 is 41. So we can write over here 120 into 41. So over here 41 into 12. So 410 4920. Calculation part please do by your own, so that you should be confident in calculation. So the sum of the first 40 positive integers divisible by 6 is 4920. Let us move to question number 13. Question number 12, 4920. So this is the answer. Now question number 13 is question number 13. Find the sum of the first 15 multiples of 8. I think you can do it by your own. I am leaving this sum. The AP will be first 15 multiples of 8, that is 8 and so on. So A you will be taking as 8 and D as 8 and S 15 you will be finding. Question number 14. Find the sum of the odd numbers between 0 and 50. So we will be writing odd numbers between 0 and 50 are 1, 3, 5 and so on till 49, and we have to find the sum of this. So here A equals to 1, D equals to 2 and Tn equals to L equals to 49. Therefore Sn equals to, first we have to find n, that is number of terms. So Tn equals to 49 implies A plus n minus 1 into D equals to 49 implies 1 plus n minus 1 into 2 equals to 49. This implies n minus 1 equals to 48 by 2 equals to 24. This implies n equals to 25. So 25 odd numbers are there between 0 to 50. Therefore Sn equals to n by 2, first term plus last term, because first term and last term we are knowing. So A plus of L. Now n value is how much? 25. 25 by 2. First term is 1 and last term is 49. So this will be 25 by 2 into 50. So this will be 625. So the sum of the odd numbers between 0 and 50 is 625. Question number 14, 625. Now I am leaving the sum from question number 15 onwards in this exercise because they are application based sums. If you feel to practice that, you can practice, and if any doubt is there, problem is there, definitely you can ask, even if it is deleted in the portion this year. Now one extra sum I am doing, sum of first n natural numbers. Solution is equals to n into n plus 1 by 2. Now this actually, if you remember, it will help you in objective sums afterwards. So given AP is 1, 2, 3 up to so on till n. Therefore Sn equals to n by 2. We can write first term plus last term as well. So over here this equals to n into n plus 1 by 2. Remember it. Number 2, sum of first n odd natural numbers. Solution. Now let us do number 2, that is sum of the first n odd natural numbers. Now here we will be writing given AP is 1, 3, 5 and so on till n. Now if I write over here n, so I will not be using the formula of first term plus last term. You see why? Now suppose over here I use the formula of A and D1, that is n by 2, 2A plus n minus 1 into D. So I'll be getting the same thing, that is 2 plus n minus 1, that is 2 n by 2, sorry, n by 2, and over here n plus 1. So I am getting the same thing as over here. Now the set of the natural numbers we are knowing 1, 2, 3 up to n. That is the nth natural number we can consider n. But the nth odd natural number we cannot write n. Nth odd natural number we write in the form of 2n plus 1. Nth even number we write in the form of 2n. Or over here 2n minus 1 also we can write depending on the value of n what we consider. So over here the nth odd natural number I am not writing in the form of any format. Simply I am writing n. So I will not be using this first term plus last term formula. I will be using this formula and I will be getting the term, means general term of the sum of the first n odd natural numbers. So let us do. Therefore Sn equals to n by 2, 2a plus n minus 1 into d, because common difference over here is 2. So it will come as n by 2, 2 plus 2 n minus of 2. So it will be n by 2 into 2n, that is n square. So we can write sum of the first n odd natural numbers is n square. Remember this, it may help you in some objective sums. So sum of the first n natural numbers is n into n plus 1 by 2. Sum of the first n odd natural numbers is n square. Let us get one more. Sum of the first n even natural numbers. Sum of the first n even natural numbers. Here also I am writing 1, 2, 3 up to n only. I am not writing the general format of the even numbers. Solution. Here the given AP is 2, 4, 6, 8 and so on till n. Therefore Sn equals to n by 2, 2a plus n minus 1 into d. So what we will be getting? 4 plus 2n minus of 2 equals to n by 2, 2 plus of 2n equals to n by 2, and over here n plus 1 and common is 2. This 2 cancel, equals to n into n plus 1. So the sum of the first n even natural numbers is n into n plus 1. So the concept or the topic or the general formula of and the types of the sums based on the sum of the n terms of an AP has been discussed. Some more sums I will be finding, or some more sums which I find is to be discussed with you, I will be discussing in the next video. So right now you will be doing all types of sums from NCERT. All the solved examples of RS as well you will be doing. So homework will be complete. Exercise 5.3 till question number, what was the last question which I did? Till question number 14, as well as the solved examples you will be doing, plus solved examples and 2 sums I am giving you from exercise 4.4, exercise 5.4, question number 1 and 2, and this question number 1 and 2 I will be discussing in the next video as well. So along with these 2 questions I will be discussing few more questions from RS Agarwal, but these 2 questions first you attempt by own, you just see whether you can do such type of sums or not. So till then, goodbye children, thank you.